welcome back. We're in 2.2, applications of linear inequalities. So at the very start of the text down below, there's a process here to go through whenever you're faced with a story problem that involves a linear inequality. It's written a little bit more in detail below, but I've got it kind of generalized here. The first step, you want to read the problem and understand the problem. Ask yourself at the end, what are they looking for? What is the solution supposed to look like, right? And gather information. While you're doing that, you can gather information, read through it once perhaps, and then gather information on a second read. But take note of important information. And then use that information to create the mathematical model, right? And this is very similar to the model that we saw before. Once you've created that, solve the mathematical model, check your answer. But also, it's good advice to ask yourself, does this answer actually make sense, right? There's questions where you maybe have, Jane is so old and her grandmother's 3 times as old as she is, and then in 10 years gives you some relation. And if you write down all of this, figure it out, get down to an answer, and it says, oh, Jane's grandma must be negative 45 years old. Probably not, right? If it doesn't make sense, maybe go back and recheck your work, redo the model, something like that, right? So let's see a couple of problems. We'll go through some and go through kind of this process and solve them. All right, so first we have, and I'll do the first example from below. It says John is a salesman and he earns a base salary of $30,000. And he also gets a 5% commission. And then he wants to earn this year at least $42,500. So that's our problem, and the question is, what will his total sales need to be? So I've kind of done step 1 and 2 together. I read through the problem, and while I read through the problem, I just wrote down the important stuff. Right? The idea here is we need to figure out the amount of sales that will make John happy with his earnings of at least $42,500. Right? So the equation, in a very general sense, is John's earnings since he wants to make at least that much, those earnings should be greater than or equal to this $42,500. But what are John's earnings? Well, there's 2 sources of earnings. He gets $30,000. But he also makes this 5% commission. So that's 0.05 multiplied by x, which is going to be the representation for the number of sales, or the amount of sales that he does. So this 30,000 plus 0.05x needs to be greater than or equal to 42,500. And that's our inequality, right? And now we just need to solve this. I'm going to go ahead and erase this so that I have some room to work here. This tells me that I've got 30,000, I'll just rewrite this up here, 30,000 plus a 0.05, the 5% of his sales, needs to be greater than or equal to 42,500. And we treat this like we've done with all of our inequalities up to this point. I'll start by subtracting 30,000 from both sides. This gives me 0.05x greater than or equal to 12,500. And then I'll divide by 0.05. Since I'm dividing by a positive, I don't need to worry about changing my sign. This gives me x is greater than or equal to, I want to say that, 450,000. That is not true, I went too far. That, 250,000. Yep. And so his sales, X represents his sales. His sales should be greater than or equal to $250,000. Anything above this $250,000, he'll be making more than he wanted to, and he'll be happy, right? So that's the idea here. To state that in terms of the problem, you would say John's sales need to be $250,000 or more. And that's it. Let's take a look at another one. Let's say a car rental costs $25 plus 30 cents per mile. Let's say Jane wants to rent a car for 2 days. And she only has, let's say $200. How many miles can she drive? So again, the idea here is the general overall equation is Jane has only $200, right? And she's going to rent a car, so the cost of renting this car needs to be less than or equal to the $200 that she has, right? Now we just need to create some expression for this cost. But that's the idea here is whatever she spends can't exceed $200, otherwise she's in trouble, right? So the cost of the car is $25 per day, but she's renting it for 2 days, right? So that's 2 times 25. 2 days at $25 a day. Plus 30 cents per mile, so 0.3 times X, times M, whatever you want. Let's call it M just for fun. That has to be less than or equal to 200. We can simplify. 2 times 25 is 50. Plus our 0.3 M has to be less than or equal to 200. So we can subtract 50 from both sides. I'm going to take this up so I have room to work it. turns into 0.3 m on the left is less than or equal to 200 minus 50 is 150, and then divide each side by 0.3. So m, the number of miles that Jane can drive, is less than or equal to 500. And that's her limiting factor. The most she can drive is 500, but if she drives anything less than that, she still keeps her cost under the 200. So this is a real world problem, and so it doesn't make sense to say strictly less than 500. Mathematically, that means she could drive negative miles, and not really in the realm of reality, right? So Jane, you can write this, if you wrote Jane or Jill or whatever her name was, I don't remember, can drive at most 500 miles, right? We would all understand that you can drive anywhere between 0 and 500 miles, right? If we wanted to write this in interval notation, we would write it typically, since strictly speaking we're less than 500, this is what we mean by that. But it doesn't, again, make sense to include these negatives. So in the real world application, we would say anywhere between 0 and 500. And we would include 0 because that she could just go rent it and say, oops, never mind, here's my $50 and walk away from it. Doesn't make sense really, but you know, I'm not Jane, I'm not her accountant. She can do what she wants with her money. But that would be the real world solution here, anywhere between 0 and 500 miles. Okay. Doesn't make sense if it's 0, why would you bother? But she could do it. Let's look at an average problem. Albert needs an average of 80% on his exams in math to math class to pass with a B. He has scores of 72, 82, 65, and 98 on the first 4. He has one more exam. The question is, what scores on his final exam, on his last exam, what scores on his last exam will satisfy this, right? So again, just the general idea here is Albert's average. Needs to be greater than or equal to, well, I'm going to say, I didn't write this, but at least. At least meaning it could be 80, anything above will also work. Therefore his average is greater than or equal to 80. this is what we want to solve. And it's this average over here that may be the little bit tricky part, but the average is just the sum of all of your exams divided by the number of them. There were 5 exams here, right? We have 4, but there's also 1 more to go, right? What's the score on the last one? We don't know, right? So the average here is the sum, that's 72 plus 82 plus 65 plus 98 plus that last exam. You have to include that in the average because that's the average of all of his tests. Divided by the 5 exams. That needs to be greater than or equal to 80. I'm going to erase what's in green here, take my problem up so I have room to solve it. So, excuse me, if I want to make life a little bit more simpler, I'm going to add all of these scores together. So that ends up being 317. Still plus x, right? I can only add the ones that are numbers, so that's all 317, still plus the x divided by the 5, right? That all has to be greater than or equal to 80. Now every once in a while you'll get a number here that's divisible by the number in the denominator, and I see people cancel those out. You cannot do that. Don't do that. This plus here prevents you from doing that, because this is 317 plus x. That whole thing divided by 5, that doesn't mean just divide one of these by 5 and you're good to go, right? So I can't do the division here. This wouldn't go nicely anyway. What I can do though is get rid of this 5 by using the multiplication principle. I can multiply both sides by 5. Multiply the left by 5, that cancels the denominator, and then multiply the right by 5. Right? So that gives me 317 plus x on the left, greater than or equal to 400, right? And then I use my addition principle, once again, subtract 317 from both sides. X is left, it's greater than or equal to, 83. So Albert or Alfred or whoever this was has to score an 83 or better. All right. Thank you, and we'll see you for the next section.